this is chapter 18, question 42. Okay, we have a compound called hep 4-enol. Okay, so they are asking what is formed when hep 4-enol is reduced with either hydrogen and a nickel catalyst or sodium borohydride. Okay, so in this hep 4-enol, we have two functional groups, alkene and aldehyde. Okay, the double bond is alkene. Then the CHO is aldehyde. Okay, now they are asking about reducing. Uh, sorry, they are asking about reduction with two different reducing agents. One is hydrogen and nickel catalyst. Okay, and also another one is sodium borohydride, NaBH4. Okay, now let's go and look at the summary table that I've made. Hydrogen and nickel catalyst can reduce both alkenes and also aldehyde in hep 4-enol. But if we are talking about NaBH4, sodium borohydride, it can only reduce aldehyde but not alkene. Okay, now knowing how these two reducing agents can reduce which type of functional group, let's go back to the question again. Alright, now this one, I would like to make the note. This hydrogen and nickel catalyst can reduce both alkene and aldehyde. Right? Then we have seen from the summary just now, this sodium borohydride can only reduces this aldehyde, but not alkene. Alright. So if aldehyde is reduced, okay, it will form a primary alcohol. Okay, if alkene is reduced, okay, it will form an alkane. Since hydrogen and nickel catalyst can reduce both alkene and aldehyde functional groups in hep 4-enol, so this part will become CH2CH2. And here you get the primary alcohol CH2OH. So let's check A and B with hydrogen and nickel catalyst. So we should get CH3, correct? CH2, 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 CH2. Okay, 1, 2, 3, 4, 5. 5 CH2, correct? And here CH2OH. CH2OH. Yes, A is correct. Now let's check through B, C, and D also. So let's look at B. With hydrogen and nickel catalyst again, okay, both will be reduced. This is reduced to alkane, this is reduced to primary alcohol, but there is no primary alcohol in B, so B is not correct. Now let's look at C and D. They are now using the sodium borohydride as reducing agent. Only aldehyde can be reduced to primary alcohol. The alkene should remain the same, no change because it is not reduced by sodium borohydride. So, but look at C. Okay, the product in C, there is no alkene. That means, okay, C is not correct because the product shown that NaBH4 has been has reduced alkene, which is not correct. B, alkene is reduced, okay, aldehyde is not, okay, which is not correct also. It should be the other way around. So the answer is A.